You close your eyes. It's dark. And then suddenly you're running through a city that doesn't exist, being chased by someone whose face keeps changing. And somehow you're also late for an exam you never took in a school you never attended. And then your alarm goes off. And you lie there for a second thinking, what was that? Where did that come from? And more importantly, why does your brain do that every single night? This is the story of dreams. Not the poetic kind, not the follow your dreams motivational poster kind. The actual biological phenomenon that happens inside your skull for roughly 2 hours every night of your life, and that scientists, philosophers, and doctors have been trying to explain for literally thousands of years. Because here's the thing nobody tells you. We still don't fully know why humans dream. And that's not for lack of trying. We have brain scanners, we have sleep labs, we have decades of research involving thousands of volunteers being woken up at inconvenient hours by scientists with clipboards. And the honest answer at the end of all of that is still, mostly, we have some really good theories.
And those theories are fascinating. So let's go through them, because the story of why you dream is also the story of how your memory works, how your emotions get processed, how evolution shaped the sleeping brain, and why the most sophisticated biological computer on the planet spends a third of its operating time running what appears to be a completely random simulation. Let's start with what actually happens when you dream, because most people have a vague sense of it, but the details are genuinely strange. Sleep is not one thing. It's a cycle. Every night, your brain moves through different stages of sleep, cycling between lighter sleep, deeper sleep, and a stage called REM sleep. REM stands for rapid eye movement, which is exactly what it sounds like. During REM sleep, your eyes move rapidly back and forth under your eyelids. Your brain activity spikes to levels almost indistinguishable from when you're fully awake. Your heart rate and breathing become irregular, and your body almost entirely stops moving. Your muscles go into a state of temporary paralysis called REM atonia. You are, in the most literal sense, frozen in place while your brain goes absolutely wild. This is when most vivid dreaming happens.
The first person to properly describe REM sleep was a researcher named Nathaniel Kleitman, along with his graduate student Eugene Aserinsky at the University of Chicago in 1953. They noticed the eye movement pattern in sleeping subjects, woke them up during it, and found that almost every time, those subjects reported vivid narrative dreams. Before this, the scientific study of dreams had been mostly theoretical. Freud had published his famous interpretation of dreams in 1900, which proposed that dreams were the disguised fulfillment of repressed wishes, windows into the unconscious. But Freud was working without any neuroscience. He didn't know about REM. He didn't have EEG machines. He was essentially doing philosophy with a medical vocabulary. The discovery of REM gave scientists something they could actually measure. And measuring is where things started to get interesting. Here's the first big theory about why we dream, and it's probably the one with the most evidence behind it right now: memory consolidation. The basic idea is this. During the day, your brain takes in an enormous amount of information. Faces, names, facts, routes, conversations, emotional experiences. Not all of it gets stored as long-term memory. Your brain has to sort through it, decide what's important, and transfer the useful stuff from short-term storage into something more permanent. And current evidence suggests a significant chunk of that work happens during sleep, specifically during REM sleep. And dreams may be, in part, the byproduct of that process. Think of it like defragging a hard drive, if anyone still does that. Your brain is running through the day's files, organizing them, compressing some, deleting others, connecting new ones to old ones. And while it's doing that, fragments of those files play out. You see people from your day, you revisit situations, sometimes accurately, often twisted into strange shapes. You make weird connections between things that don't obviously belong together. That's not your brain being random. That's your brain doing the organizational work it doesn't have time to do when you're conscious and demanding that it focus on whatever's in front of you.
The evidence for this is remarkably solid. Studies consistently show that people perform better on memory tasks after a full night's sleep, and specifically after getting adequate REM sleep, compared to people who sleep the same amount of time but have their REM interrupted. Matthew Walker, a neuroscientist at UC Berkeley and author of Why We Sleep, has described REM sleep as overnight therapy, a period where your brain processes emotional memories specifically, replaying them in a neurochemical environment that's stripped of the stress hormone norepinephrine, allowing you to revisit difficult experiences without re-traumatizing yourself. You process the emotion without being flooded by it again. This, Walker argues, is why we often wake up from a night of sleep feeling better about something that upset us the night before. It's not just time, it's REM.
The second major theory is threat simulation, and this one is older in an evolutionary sense and slightly more unsettling. The idea was developed primarily by a Finnish neuroscientist and philosopher named Antti Revonsuo, and it goes like this. Dreams, especially threatening dreams, and look at your own dream history, they lean threatening pretty heavily, are a kind of rehearsal mechanism. Your sleeping brain runs simulations of dangerous situations so that your waking self is better prepared to handle them if they actually occur. Think about what the ancestral human environment looked like. You're living in a small group, out in the open, surrounded by predators. You're at constant risk of violence from other groups. You're dependent on reading social dynamics correctly or being cast out, which in that environment means dying. The ability to mentally rehearse those scenarios, to practice threat detection, to run through possible responses, that would have been enormously useful. And if dreams are the mechanism your brain uses to do that, then the terrifying quality of nightmares isn't a bug, it's a
Your brain running a high-stakes simulation needs to feel high stakes, or you won't engage with it properly. This theory explains a lot about the content of dreams that memory consolidation alone doesn't fully account for. Why are dreams so often emotionally intense? Why do they so frequently involve being chased, falling, being in danger, losing something, failing at something? Why do so many people across so many cultures report the same recurring dream themes despite having completely different waking lives? Threat simulation theory says these aren't coincidences. These are your brain rehearsing the scenarios that matter most for survival, the scenarios evolution decided you should be ready for. There's a third theory that gets less press but is genuinely fascinating, and it comes out of the field of computational neuroscience. It's sometimes called the activation synthesis hypothesis, first proposed by psychiatrists J. Allen Hobson and Robert McCarley in 1977.
Their idea was controversial when they published it, and still generates debate. The basic claim is this: dreams don't mean anything, at least not in the way most people think. During REM sleep, your brainstem fires random electrical signals up into your cortex. Your cortex, being a narrative-making machine that cannot tolerate randomness, takes those signals and does what it always does. It builds a story. It pattern matches against your stored memories and experiences and constructs the most coherent narrative it can from essentially random input. The resulting dream feels meaningful because your brain is the one making it, but the raw material is noise. Hobson and McCarley were not saying dreams are worthless. They were saying the meaning is constructed afterward, by the dreaming brain, and then again by the waking brain reflecting on the dream, not encoded in the signal itself. It's the difference between a message and a Rorschach test. The meaning is real. The meaning tells you something about the person constructing it, but the original signal wasn't trying to communicate anything. It was just firing. If dreams are your brain's attempt to make narrative sense of random activation, then every dream is a piece of improvised storytelling generated by the most complex system in the known universe, using your entire life's experience as its source material. The stories are yours. The raw signal might be noise, but the dream itself is not. Now, here's something that cuts across all three theories and doesn't get talked about enough. Emotions. Not just the presence of emotions in dreams, which anyone who has woken up from a dream crying or furious or flooded with joy knows about, but specifically the type of emotions that dominate dreams and what that distribution tells us. Research on dream content, collected from thousands of dream reports over decades, consistently finds that negative emotions are far more common in dreams than positive ones. Fear,
anxiety, sadness, frustration, embarrassment. These show up in dream reports at much higher rates than joy, contentment, or pleasure. Across cultures, across age groups, across genders. This is not because the world is mostly terrible, at least not entirely.
It's because your brain's emotional processing system, particularly the amygdala, which is basically your internal alarm system, is highly active during REM sleep. And an active amygdala is going to weight things toward threat, toward danger, toward the scenarios that need processing. Your brain isn't trying to make you miserable in your dreams. It's trying to make sure you're ready. The negative emotional weight of dreams is, from an evolutionary perspective, the whole point. You don't need to practice being happy. You need to practice surviving. There's another angle here that's worth sitting with: lucid dreaming. This is the phenomenon where a dreamer becomes aware, while dreaming, that they are in a dream, and in some cases can then exert some degree of control over the dream's content. Lucid dreaming is real. It's not a fringe claim or a pseudoscientific idea. It's been documented in sleep labs. Researchers figured out a way to verify it by prearranging signal patterns, like specific eye movements, that a lucid dreamer could perform while in REM sleep to communicate to researchers outside. The signals showed up. Lucid dreaming is a confirmed phenomenon.
What's interesting about lucid dreaming from a scientific standpoint is what it reveals about the dreaming brain. During a lucid dream, the prefrontal cortex, the part of your brain associated with rational thought and self-awareness, shows increased activity compared to regular dreaming. During normal dreaming, the prefrontal cortex is largely offline. This is why dreams feel real while you're in them. The part of your brain that would recognize the absurdity is asleep on the job. Lucid dreaming is what happens when that part wakes up just enough to recognize the situation without ending the dream. Some people can train themselves to lucid dream more reliably, and researchers are interested in this not just as a curiosity, but because lucid dreaming has shown potential therapeutic applications for people who suffer from recurrent nightmares, as in PTSD-related nightmares. If someone can learn to recognize they're in a nightmare and alter its course, that's a meaningful intervention. The dream space becomes not just something that happens to you, but something you can, at least partially, navigate.
Let's talk briefly about the cultural history of dreams, because it's enormous. Ancient Egyptians believed dreams were messages from the gods. They had professional dream interpreters who worked in temples. If you had a significant dream, you might seek out a priest who would help you decode it. The ancient Greeks shared this belief and added the idea of incubation sleep, where you would sleep in a sacred space, often a temple of Asclepius, the god of medicine, specifically to receive healing dreams. Sick people would travel significant distances to sleep in these temples and hope that the god would visit them in their dreams and tell them how to be cured. The ancient Mesopotamians, the people who gave us the first written literature, compiled elaborate dream interpretation manuals. Thousands of clay tablets have been found containing catalogs of dream imagery and their supposed meanings. The Epic of Gilgamesh, one of the oldest stories ever written, features multiple prophetic dreams that drive the plot. The dream as plot device and as divine communication is basically as old as literature itself.
In ancient China, there was a concept of the soul leaving the body during sleep to travel and have experiences, and dreams were the memories of that journey. In many indigenous cultures across the Americas, Africa, and Australia, dreams were considered access points to other layers of reality, not less real than waking experience, but differently real. The Aboriginal Australian concept of the dream time is not about sleep at all in the way we understand it, but it reflects how foundational the concept of an alternate experiential reality accessed through dreaming has been in human culture. Freud arrived at the end of a very long tradition and tried to translate it into modern scientific language. He wasn't wrong that dreams have psychological content worth examining. He was just working without the tools to understand where that content came from mechanically. The subconscious he described is real. The mechanisms he proposed to explain it mostly weren't.
So,
where does this leave us? Here's what the science actually agrees on, as of right now. Dreams happen primarily during REM sleep. They are generated by a brain that is highly active, emotionally charged, and largely cut off from the rational oversight of the prefrontal cortex. They draw on memories, emotions, and experiences in ways that serve some combination of memory processing, emotional regulation, and possibly threat rehearsal. The specific content of any given dream is shaped by what's active in your brain, what's weighing on you emotionally, and to some degree, random activation patterns that your brain then narrates into coherence. What dreams mean, in the deeper sense, of why you had that specific dream about that specific person in that specific impossible location, that's still genuinely contested. The evidence does not support the idea that dreams are encrypted messages from your unconscious that can be decoded symbol by symbol. A falling dream does not universally mean something. A recurring dream about your teeth falling out is probably not the universe telling you something specific, even though an alarming number of people have it. What it probably means is that your brain is processing anxiety.
And teeth falling out is a threat simulation your brain finds resonant, perhaps because it connects to fears about appearance, loss of control, or physical vulnerability. The anxiety is real and worth paying attention to. The teeth are probably not the point. Here's what we know with confidence. Dreams are not random noise. They are not meaningless. They are not divine messages. They are, based on the best current evidence, a byproduct and possibly a mechanism of a sleeping brain doing incredibly important maintenance work on your memory, your emotions, your sense of self, and possibly your readiness to handle whatever the world throws at you next. The content is yours. The stories are generated from everything you've ever experienced.
And the fact that you experience them as real, as vivid, as emotionally true, that's not a malfunction. That's the whole system working exactly as designed. You spend roughly 6 years of your life dreaming. 6 years inside a world generated entirely by your own mind, drawing on everything you've ever seen, felt, feared, or loved. That's not nothing. That's one of the most intimate and unexplored territories in human experience. And the fact that we still don't fully understand it, after all the brain scanners and sleep labs and thousands of years of trying, says something important. Not about the limits of science, about the depth of what's happening inside us every single night, while we think we're just asleep. Close your eyes tonight. Your brain has work to do.